Dear students, welcome to today's lecture. So, we would as always would begin with a brief recap of what we had covered in last lecture and then go on from there. So, in last lecture we had discussed two things main. So, how to calculate arithmetic mean given a data set. So, arithmetic mean represents one of the most widely used metrics for representing your data, and we also briefly discussed about transformations. Is given a data set, how can you make use of transformations to make it easier for you to calculate arithmetic mean, particularly if you are doing it by hand. Okay. So, there were three main transformations we had discussed in last class: y is equal to ax, y is equal to c plus x, and y is equal to c plus ax. So, just to give you an example, if you let us say have numbers like 10, 20, 22, 35, 46, 78. So, what should you do? So, what you see, there are two things which are going on. These are increasing roughly in terms of in jumps of 10 or so, and you have a range from 10 to 80, right. So, either what we can do is, so particularly if you are doing by hand, and in this particular case there are only 5 numbers. So, we can even add up by hand. So, one possibility is divide by 10. Okay. So, then you have the numbers 1, 2.2, 3.5, 4.6 and 7.8. These you can add up by hand very easily. The second possibility is like we did, we identify the smallest number, which is 10, the largest number, which is roughly 80, so which is 90. So, so the average is roughly 45. So, average here is roughly equal to 10 plus 78 by 2, which is roughly equal to 45, sorry 80, 90. So, 45. So, we can apply the transformation y is equal to x minus 45 here, and then in that case my numbers will be minus 35. Okay. So, y values are minus 35, minus 23, minus 10, plus 1, plus 33. Okay. Then I can add them up very easily and find out what is my average. Okay. So, what you see that there is not one rule which will make things work, depending on what kind of transformation you use. There can be more than one rule. Okay. So, that is one thing. So, today we will discuss the next thing, which is, let us say you have a discrete data set. So, if you look at the data set here, so you have numbers which are all first of all discrete, and then they are repeated. Okay. So, if this was entire data set, what you can clearly see is the number 10 has been repeated. So, by frequency, these are my x values, my frequency 10 has been repeated once, 20 has been repeated once, 30 has been repeated twice, 40 has been repeated once, 60 has been repeated 1, 2, 3, 4 times, and 70 has been repeated 2 times, no sorry 3 times. Okay. So, what you see, these are discrete values which are repeated. So, if I were to go back to the way we calculated our average, we want to do, so in general we can write it as frequency is f1, f2, f3, so on and so forth, and these guys we call as x1, x2. So, we can calculate my x bar is simply x1 into f1 times plus x2, which has been repeated f2 times, plus x3, which is repeated f3 times, so on and so forth, plus xn, which has been repeated fn times. Okay. And we want to divide by the total number of observation, which is nothing by f1 plus f2 plus f3 plus dot 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 plus fn. Okay. So, we can, the final expression becomes x bar is nothing but summation fi into xi by summation fi. Okay. So, as as before, I did not put the start and end values, but this just summation alone means that I am doing a sum from I is equal to 1 to I equal to n. Okay. So, you can do this as an exercise. So, you know what are the values of f1, f2, what are the values of x1, x2, and please calculate the final average. Okay. So, this is what it is. You can have to basically calculate the frequency of each number, each discrete variable and the value, and then calculate the total sum as per this particular equation. Now, let us, I wanted to discuss one more thing. So, even in this case, let us say this example that we took, the variables are 10, 20, 30, so on and so forth, right. So, you have a range. So, your minimum value is 10, your maximum value is around 70, okay, fine. You have a range. So, you can see that the jump is roughly by 60. Imagine I have data which is 1, 2, 3, 4 and then 45, 89, so on and so forth. So, what I can clearly see is if I take a mean, arithmetic mean, I will get a value which is going to be much greater than these two, and it will be much more biased toward these bigger numbers, right. So, this is one of the principal weaknesses of calculating arithmetic mean. If you have large variation in your data set, then arithmetic mean might give you a value which really does not mean anything. Okay. So, what might be an alternative in our approach to come up with a better number? So, one number which is often used, or which is used to calculate this, is called the geometric mean. Okay. So, as opposed to adding up the numbers, you take their product and you take their root, nth root. Okay. So, if we have n numbers x1, x2, x3 dot 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 xn. So, the way we do geometric mean, and in short we write GM is equal to nth root x1 into x2 into x3 dot dot xn. So, the way to write it in short mathematically is to write nth root and you put this thing called pi, okay, pi of xi, okay, and I is equal to 1 to n here. So, this means product. Okay. So, if I is equal to 1 to n equal to 1, then it will simply be 1. If n is 5, then you have x1, x2, x3, x4, x5, so on and so forth. Okay. So, this is a simple representation of geometric mean. Now, let us take an example and see what this what this rule does. So, imagine you have a data set as follows, which is 15, 10, 5, 8, 17, 100. So, my numbers are 15, 10, 5, 8, 17, 100. Okay. So, if I were to sort these numbers and put them next to each other in terms of ascending order. So, I have 5, 8, 10, 15, 17, 100. So, but just by looking at the data, I can clearly see that the number 100 is really an outlier. In other words, outlier means maybe this data was taken when there is some error in the procedure of acquisition of data, some experimental error, because I can see that my number is the other numbers are much closer to each other. So, here my 5 to 17 range is 12 only, right. So, 17 minus 5 is 12 versus 100 minus 5 is 95. Now, how can I, so if I account for 100 in calculating the average, what number do I get? So, my arithmetic mean x bar becomes 13 plus 25 plus 17 plus 100, so you have 6 numbers, right. So, 30, 55, 155, 155 by 6 is equal to 12, 55. So, if I were to roughly write, it is close to 26, okay. It is close to 26, okay. The exact value is 25.8, okay. Now, so clearly I can see that 25.8 would be a value which is right here, which is way further than most of the other numbers. So, really this arithmetic mean gives me a number which is not representative of the whole population. How can I come up with an alternate number? So, geometric mean is one such approach to get a number which is much more representative of your data. So, if I do the same exercise with the geometric mean, so what I get is a value of 14.7, which is still much so. We have a value which is which is between 10 and 15. So, which is still more representative of the population. So, you have changed from 25.8 to 14.7. So, this is one of the big advantages of geometric mean over arithmetic mean, particularly when your data set, in your data set there is huge heterogeneity and there are 1 or 2 values which are way larger than what is the most of the other values. Okay. So, there is one more important measure. So, let us say that you draw a histogram and you plot the data, okay, and your plot data looks like this, right. So, logic would dictate that if you do the arithmetic mean of all these population, okay, your arithmetic mean will somewhere lie here. This is where your arithmetic mean lies. Okay. Now, there is one more way of doing it. Okay. So, what you can do is you can sort these numbers, entire numbers x1, x2 up to xn in ascending or descending order, and try to find which is the number which is directly in the middle. Okay. So, it is some way it would be a very nice alternative to the arithmetic mean, and this particular metric has a name, it is called the median. Okay. So, this is how you define the median. The median of a set of n measurements is the value that falls in the middle position when measurements are ordered from smallest to largest. Okay. So, of course, whether you order from smallest to largest or largest to smallest, that does not matter, but so you basically find the number which is at this position, which is 0.5 times n plus 1. Okay. So, let us do the previous numbers. You had, if I go back to the previous slide, and my numbers were 15, 10, 5, 8, 1700. Okay. 15, 10, 5, 8, 17 and 100. So, if I sort them and I write it together, 5, 8, 10, 15, 17, 100. Okay. So, this is a sorted list. Okay. So, I put them together. So, I have these numbers 5, 8, 10, 15, 17, 100. What is my n? N is the total number of numbers I have, which is 1, 2, 3, 4, 5, 6. So, my median position is what? Is equal to half into n plus 1, right. So, 0.5 times n plus 1 is equal to 0.5 into 7 is equal to 3.5. Okay. So, 3.5 means what? The position is somewhere right in the middle of 10 and 15. Okay. This is the third number, this is the fourth number, but my median is the number which is right at position 3.5. So, how do I find the number which is 3.5? So, I use what is called as interpolation. Okay. So, my median as per this will be the average. So, will be 10 plus half into 10 plus 15. This is the position. Okay. It is middle of this. So, will be 10 plus half into 10 plus 15 is 12.5 is equal to, so, and then its position is half. Sorry, it is simply at this position, it is going to be half into 10 plus 15 is 12.5. So, your median is 12.5. Okay. So, you get a number which is even better. So, it is much more representative of this entire data set. The effect of 100 has completely been eliminated. So, and the other advantage is median is of course much more easier to calculate than geometric mean. Okay. So, let us solve another problem of calculating the median. Okay. So, let us take this following data set again. So, what I can have, so let me first count. So, I want to calculate the median, right. I want to number them and I want to see what is the, so first of all how many numbers do I have? I have 1, 2, 3, 4, 5, 5 into 5 is 25. So, n is equal to 25. I want to order their numbers together. So, I have to sort them in terms of lowest to highest number. Okay. So, my lowest number is 18.3, the next highest number is 19.2, the next highest number is 19.2, you have 20, 20, 20, 20, the next highest number is 20, I have 121 here, after 21 I have 23 here, so 23, after 23 is 24.3 is there here, and 24.2 is here. So, 24.2, 24.3, okay, 24.2, 24.5, then after 24.5 you have 25, you have 25, 25.2, 25.6, sorry, there is 25.5 also, then 25.6, so 25.5 is there, 25.6, after that you have 26.6, okay. Then after 26.6 you have 27.5. So, I can write the remaining numbers. Now, I know that n is 25, right. So, my median position is basically, so half into n plus 1 position is equal to half into 25 plus 1 is equal to 13, right. So, I did not complete it, but whatever number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, your median is 25.6. So, median is 25.6. Okay. So, sometimes you will get an exact value. So, if your number of data is odd, so when n is odd, then half of n plus 1 will give you an exact value. So, you directly choose this value, but when n is even, half of n plus 1 will give you an a fraction. So, you have to interpolate between two numbers, as was the case previously. So, in this case I had 6 observations. So, my median position was 3.5, in which case I had to interpolate between the two numbers, but when n is equal to odd, okay, so I can get the exact value because this is an exact position. So, I can just collect the number at that position. Okay. So, there is one more metric, okay, there is one more metric which is often used. This is called the mode, the most frequently occurring value. Okay. So, in our case, so let us say for example, this is a data set of number of visits to a dental clinic in a typical week, and we can see that which is the most frequently observing value. So, let us tabulate again. Okay. I have my x and I have my frequency. Okay. So, number of visits 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9. Okay. So, frequency for 1 is 2, frequency for 2 is 1, frequency for 3 is 1, 2, 3, frequency for 4 is 1, 2, 3, 4, 5. So, frequency for 5 is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Frequency for 6 is 1, frequency for 7 is 1, 2, 3, frequency for 8 is 1, 2, frequency for 9 is 1. Okay. So, clearly you look at the frequency column, identify the maximum number which is 7, that means your mode is 5. Okay. So, mode is the most frequently occurring value which is 5. So, on an average 5 number of visits are there in a given week. Okay. But let us say in this you did this, you went through this exercise, and let us say hypothetically, let us say you have another case where even 4 gives you the number 7, or 1 also gives you the number 7. Then what do you do? So, you do not have one unique answer, and that is exactly what brings us to this plot, where you have your distribution might be unimodal. That means there is a heap which is with a unique peak, okay, or you can have bimodal, and there are 2 peaks in this curve. So, this is a bimodal distribution, in which case you have to report both the mode values versus a unimodal distribution. Okay. So, now that we have 3 different metrics of quantifying the data, one is mean, one is median, one is mode. So, which one do we choose? Which one do we choose? So, a rule of thumb is mode is used for large data sets, let us just say for hypothetical case you had only 5 observations and these observations 1, 2, 2, 4, 5. So, in this case reporting a mode does not make sense because your data set is too small. Okay. So, in this case it is better to do either a mean or a median. So, as a rule of thumb, if you look back at the rule of thumb, mode is used for large data sets. Now, what is large? If you have 50 observations, I would say that is a reasonable number to calculate or to report mode as one of the representative metrics. The other two metrics, mean and median, are used for both small and large data sets. So, as we said that one of the caveats of mode is depending on your distribution you may not have one unique value, but there might be more than one, but both mean and median gives you one particular value. The other beauty about median is insensitive to outliers, as we had seen in the previous case, where we could clearly see that if when we are doing the arithmetic mean, this guy 100 will directly influence your observations, but when you are doing the median, then essentially you are finding out the position which is here, and then that eliminates the possibility or effect of outliers. Okay. So, this is one of the beauty of this median metric, that median is less sensitive to outliers, but you have multiple values which are all big and they are spread across, then median might have a value. There is another way of thinking about when to use mean, when to use median, and when to use mode. Okay. So, let us say you did experiments where there were two conditions or two experimental conditions A and B, and you have obtained your data set and you want to ask, do A and B differ? Okay. In other words, if I so let us say you have done your frequency histogram, this is for condition A, and for condition B this is for condition B. Okay. So, from a peaked distribution which has a distinct maxima, B is reasonably flat, in other words all values are equally reasonable. So, clearly this would tend to say that there is a big difference. So, and you can report mode as this value, but in the example that I took there is no mode to report. Second thing is A bigger than B, in that case median might be a good way to look at it. Okay. And last, how much you want to quantify the extent to which A and B differ, and in that case we can report the mean. Okay. So, there are different contexts in which you might use a mean, a median, or a mode. Let us go through few examples where we compute all these three quantities. Okay. So, let us again come to this particular example, the number of visits to a dental clinic in a typical week, right. So, what we wanted to show, I had calculated that frequency distribution. Okay. So, this was the frequency distribution earlier. Okay. So, my mode, let me rewrite. Okay. Let me rewrite. Okay. So, I have x and I have frequency. So, you have values of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, 1 is 2 times, 1 is 2 times, 2 is 1 time, 3 is 3 times, 4 is 5 times, 5 is 7 times, 6 is 1 time, 7 is 3 times, 8 is 2 times, 9 is 1 time. Okay. So, for this particular distribution we want to identify, the mode which we already have. So, my mode is equal to 5. Let us calculate the mean then. So, mean I can use the formula x bar is equal to summation f x by summation f. This would give the value 1 into 2 plus 2 into 1 plus 3 into 3 plus 4 into 5 plus 5 into 7 plus 6 into 1 plus 7 into 3 plus 8 into 2 plus 9 into 1 by total number of observations is 2 plus 1 3, 3 plus 3 6, 6 plus 5 11, 11 plus 7 18, plus 1 19, 19 plus 3 22, 22 24 25. So, let us calculate the sum here. So, here we have 2 plus 2 4, 4 plus 9 13, 13 plus 20 33, 33 plus 35 68, 68 plus 6, 74, 74 plus 21 is 95, 95 plus 16 is 101, 101 plus 9 is 110. So, it is 110 by 25. Okay. So, let us go to the next page. So, we had found mean is equal to 110 by 25, 4 plus 4.4. Mode we have found out as 5, and median. So, if we arrange the numbers, okay, so for calculating median, we have to arrange the numbers. We have 1 1, 2 2, 3 3 3, 4 4 4 4 4, 5 5 5 5 5, 1 2 3 4 5 6 7, 6 7 7 7, 8 8 9, right. So, I want to find out. So, median is at position half into 25 plus 1, which is position 13. And what is position 13? 1 2 3 4 5 6 7 8 9 10 11 12 13. So, we get a median is equal to 5. So, these are your 3 observations. You see in this particular case, mean, mode, median, they are all very close to each other, but still there is a difference. Okay. So, in the general context, if I were to draw the curves, so in the best case situation, we will discuss this particular curve, which is a Gaussian or a Gaussian distribution, a Gaussian or a normal distribution. For this particular case, mean equal to mode equal to median. But for all other cases, in general, so this is one particular case, but your data might look like this or data might look like this. Okay. So, this is x and this is frequency. Okay. So, in this case, for example, let us say this is my mode. My median is right in the middle, median will probably be somewhere here. So, this is my median, and average will somewhere like here, this is my mean. So, in this case I have mode less than median, less than mean. Okay. And in the other case, so this is case B, this is case A where all the 3 is equal. So, this is case B, and for case C you will have mean less than median less than mode. Okay. So, with that you get an idea that you can have 3 metrics, mean, median, mode, and then depending on your data set. So, you know how to calculate mean, median, mode, and you see that depending on the data set, either there will be a left shift of the data as in case B here, or there will be a right shift of the data as in case C here, or in the best case situation, if you collect enough statistics, most processes in nature follow the normal distribution. So, you will have this distribution, in which case whether you do the mean, median, mode, you will get the same value. With that, I thank you for today's lecture. We will meet again in next week. Thank you.